Hello everyone. Good evening. Myself, I am Faaiz. I'm from AIIMS Nagpur. Our today's topic is electrical potential, dipole, and properties of conductor. Okay. Our first, see what is electric potential. Yeah, electric potential. Electric potential due to point charge is KQ by R. As simple as that. And electric potential is a scalar quantity. Yeah, so we can just add, subtract. So see, for an example, suppose at 4 centimeter distance on both sides, okay, we have a QQ charge. Suppose here it is minus Q and here it is plus Q. Okay, what is the potential at 3 centimeter along y axis? What will be the potential? See, potential due to plus Q. Yeah, potential due KQ by R. Simple. So KQ R will be, if it is 3 and it is 4, then it will be 5 centimeter. So KQ by 5, right? That will be the potential due to plus Q at this point. KQ distance again same 5, KQ by 5, but that will be minus because of minus charge. So we know electric potential is a scalar. Electric potential is a scalar quantity. So scalar quantity is a plus and minus. So the net potential will be, yeah, V plus Q is plus KQ by 5 and V minus Q is minus KQ by 5. So the net potential will be, yes, 0, right? Okay. Yeah, because electric potential is a scalar quantity and electric potential V is equal to KQ by R. Simple. Yeah, this is our first question. See, charges are placed on the vertices of a square as shown. Let E be the electric field, vector E be the electric field, and V the potential at the center. Okay, this is the center. If the charges on A and B are interchanged with those on D and C respectively, then okay, see. So this is actually two cases. Okay, in first case, this is square, and we have Q, Q, minus Q, minus Q. Okay, so at center electric field at center will be how much? Because of this minus Q, electric field towards this, minus Q again towards this, plus Q also towards this, plus Q towards this. So net electric field at center towards minus Y direction. Okay, minus Y direction. Yeah, some magnitude will be there, but direction will be towards minus Y. That's all. And potential at the C will be C from center 2 plus Q and 2 minus Q are equidistant. So that means, yeah, we will get 2 plus potential and 2 minus potential that are equal in magnitude, scalar addition. So potential at center will be 0. And in second scenario, in second case, what is, they interchanged the charges. Yeah, they interchanged the charges. Means A and B are interchanged those on D and C. Okay, so minus Q will come here, minus Q will come here, plus Q, plus Q. Again, yeah, again similar, again see. So electric field at center will be minus Q towards minus Q, and due to plus Q, yeah, repulsion C. So net electric field will be towards plus Y direction. Am I right? But potential will be again 0. Why? Again, see, 2 minus q and 2 plus q are equidistant from the center. With scalar addition, net will be 0. So potential remains same, but see, electric field has different direction. Electric field is a vector quantity. If its direction changes, that means electric field changes. That's all. So electric field changes and potential remains unchanged. So option A will be the correct answer. Option A will be the correct answer. Yeah. This is our next question. See, two isolated conducting spheres S1 and S2. S1 and S2. S1 and S2 of radius 2r by 3 and r by 3 have 12 microcoulomb and minus 3 microcoulomb respectively and are at a large distance from each other. Okay, they are now connected by conducting wire. They are now connected by conducting wire. A long time after this is done, the charges on S1 and S2 are respectively. So after connecting the conducting wire, what will happen? See, yeah, after connecting, okay, this is S1, this is S2. So after connecting, what will happen? These charges will redistribute such a way that, yeah, potential of both spheres will be equal. That means V1 should equal to V2. That is the final condition. And we can say by conservation of charges, yeah, Q1 plus Q2 will be how much? Total, what is the total charge before connecting the conducting wire? 12 minus 3, that is 9 microcoulomb. So yeah, by conservation of charge, Q1 plus Q2 is equal to 9. And after connecting the conducting wire, the potential of both the spheres will be equal. So what will be V1? KQ by R, right? KQ by R. KQ by R. See, respecting large distance, so we can consider as a point charge also. So potential will be K Q1 divided by first sphere's radius is 2r by 3. Means into 2r is equal to KQ2 by radius is r by 3. So yeah, wait. So potential of first sphere will be KQ1 by 2r by 3 is equal to KQ2 by r by 3. Easy. R by 3 we can cut. KK we can cut. So Q1 is equal to 2Q2. We have another equation by conservation of charges. Q1 plus Q2 is equal to 9. So Q1 plus Q2 we can write as, wait, Q1 we can write 2Q2. 2Q2 plus Q2 equal to 9. That means Q2 is equal to 3Q2 is equal to 9. So Q2 is equal to 9 by 3, 3. Q1 will be how much? Wait. Yeah, Q1 is equal to 2Q2. No doubt. And we know that 9 is equal to Q1 plus Q2. Right? 9 is equal to Q1 we can write 2Q2, 3Q2. So Q2 is 3 and Q1 is 2Q2. That means 6. So sphere 1's charge will be 3 microcoulomb and sphere 2's charge will be 3 microcoulomb. So 6 and 3. No, not 3 and 6, 6 and 3. So the answer will be option D, 6 and 3. Right. Yes. This is our next question. Wait. An electric charge 10 raised to minus 3 microcoulomb is placed at the origin 0, of xy coordinate system. 2 points A and B are situated at root 2, root 2 and 2, 0 respectively. The potential difference between the points A and B. See, first, let's draw the picture. What's the picture? This is the picture. An electric charge 10 raised to minus 3 microcoulomb is placed at the origin. So this is the origin, right? This origin 0, 0. We have charge Q, capital Q, which is equal to 10 raised to minus 3 microcoulomb, right? Okay. 2 points A and B are situated. A is at root 2, root 2. A is located at root 2, root 2. Suppose here A at root 2, root 2. And B situated at 2, 0. So B's position is here 2, 0. You have to find the potential difference between the points A and B. So see, VA will, because of this plus Q charge, that is 10 raised to minus 3 microcoulomb, KQ by this distance. This distance will be how much? Root of root 2 square plus root 2 square. It is root of 2 plus 2, that is root of 4, that is 2 by 2. And VB will be KQ upon this distance, that is also 2. That means, VA is equal to VB. So the potential difference will be how much? 0 only. Why? Because they both points are at equidistant from 10 raised to minus 3 microcoulomb. That's all. So answer is option C, 0. Okay. Yes. Yeah. This is our fourth question. See, 512 identical drops of mercury are charged to a potential of 2 volt each. The drops are joined to form a single drop. The potential of this drop is conservation of volume and conservation of charge. And potential, conservation of potential. Again, see, this is a small drop having radius r. Okay, and charge q. And it's given as this kq by r is 2 volt, right? And 512 such small drops joined to form a big drop, a single big drop. So radius is r. Okay. And see, by conservation of charges, the charge of big sphere will be 512q. Yes, 512 small spheres, small drops. So total charge will be finally 512q. Yeah, easy. Okay. And how do we find the final radius of the single drop? By conservation of volume. So initial volume is 512 into 4 by 3 pi small r cube is equal to 4 by 3 pi capital R cube. Final volume 4 by 3, 4 by 3 we can cut. So 512 R cube equal to capital R. We know that 8 cube is how much? 512. So actually capital R is, capital R is 8 times of small radius R. Easy. So we got the radius of the single drop. Okay. Yeah. Then it's very easy. We know that final potential will be, that's the question. The potential of this drop, the final potential of this drop will be K into Q is how much? 512 small Q. R is 8R. Okay. and 512 by 8 into KQ by R. This KQ by R is how much? 2. So final potential will be 512. Potential of the single drop will be 512 by 8 into 2. 4. 512 by 4. How much? 1, 11, 2, 3, 8. Yeah, 128 volt. So answer will be 128 volt. Easy question, yes. In next, see. Now let's discuss some properties of potential. Okay. You know that potential V is equal to a point charge is KQ by R. I have already discussed that. What is potential energy? Yeah. Potential energy is charge into potential, or change in potential energy will be charge into change in potential. Easy. Yes. Next. Yeah. I have discussed work done by conservative force is minus change in potential energy, and work done by external agent is plus change in potential energy if kinetic energy, change in kinetic energy is 0. Okay. Okay. So we can write like this, no? Work done by conservative force is equal to minus. What is potential energy change? Yeah. Minus Q into delta V. Easy. Again, work done by external agent is equal to Q delta V. Okay. No doubt. Yeah. So this is our question. Change in potential energy equal to Q into change in potential. Okay. The next is C. V is equal to integral E dot ds. Where is the electric field vector? Okay. So delta V. Yeah. Delta V is integral E dot ds. Integral initial final E dot ds. Okay. These are our formulas. Yeah. Just mark it out now. So delta V will be V final minus V initial equal to integral E dot ds. So next formula is V final minus V initial equal to integral initial to final electric field vector dot ds, displacement vector. Easy. Yes. And next. So from this, you have to find out electric field also. An electric field will be, yeah, del V by del xi cap minus del V by del y j cap minus del V by del z k cap. This is also very important. So 3 equations. Change in potential energy will be change in potential energy is equal to change in potential energy is equal to Q into change in potential, and Vf minus V initial is equal to integral I to F E dot ds, and electric field vector is equal to, yeah, minus del V by del x I cap minus del V by del y j cap minus del V by del z k cap. Easy. Yeah. Let's do one question. Okay. See, a positive point charge is released from rest at a distance r0. So here, yeah, here what we have, what we did is we released a point charge. The speed v of the point charge is a function of instantaneous distance r from the line charge. So of course, yeah, this point charge will feel what? A repulsion, because okay, so this is the scenario. Okay, we have a line charge distribution at r0 distance placed at a point charge. Easy. Whenever electric field at here is equal to 2k lambda by R. Easy. Okay. And from work energy theorem, we also known as work done is equal to change in kinetic energy. So here work done will be integral f dx. Easy. What is the force? Force will be electric field into charge, right? So force will be F is 2k lambda, that is EQ, 2k lambda by R into point charge Q, right? So, okay, I'm taking X because, yeah, at any distance X, dx. So by integrating this 2k lambda Q, integral dx by X. What is the integral dx by X? Yes, ln X. So 2k lambda Q, ln X. Okay, R0 is initial and R is the final position. Yeah, R0 is initial position, right? And finally 2k lambda Q. Okay, ln X minus ln R0 minus ln R. So ln R0 minus ln R we can write as ln R by R0. So ln R by R0. ln R by R0. Okay, this will be the work done, right? So this will be equal to change in the kinetic energy. Initial velocity is 0, then initial kinetic energy is 0. So change in kinetic energy means final kinetic energy minus initial kinetic energy. Initial kinetic energy is 0. So only final kinetic energy, that is half m into v square. That means v, see, from where we have to find out the proportionality only. So v square proportional to ln r by r0. So v proportional to root of ln r by r0. Easy. So v proportional to root of ln r by r0. B so answer. Easy. Yeah, work done by net, work done by all forces is equal to change in kinetic energy, and ln, see, this will become ln r minus ln r0. Yeah, then we can write ln r by ln r0. Easy, right? So we got the answer. Yes. Next, see, potential due to ring. Potential due to ring distribution of charges plus total charge is q, and potential at center Vc is equal to kq by r. This distance is r. Easy, yes. And at axial point, this is the charge. This is the ring of charge. Charge is suppose plus q, and radius is r. And from distance x at point P, what will be the potential? Potential at P will be, yeah, simple formula, kq divided by root of r square plus x square. See, at center x will be 0, root of r square, that is r. That is kq by r. Easy. Okay. And due to disk, yeah, a ring is over, then disk. Due to disk, charge q at distance x p, vp will be sigma by 2 epsilon. Yeah, then r is a radius. Radius of the disk. Root of x square plus r square minus x. Easy. So at center of the disk, potential will be sigma by 2 epsilon. X will be 0, then root of r square, yeah, into r. Easy. Easy peasy. Right. Okay. So let's move on to next question. So yeah, a ring at center potential is how much? Kq by r, and due to disk, this is a ring, and due to disk, potential at center is sigma by 2 epsilon into r, where sigma is of the charge density. Okay, let's move on to next question. This is our next question. A uniformly charged ring of radius 3a and total charge q is placed in xy plane centered at origin. A point charge q is moving towards the ring along the z-axis and has speed v at z is equal to 4. At the minimum value of v such that it crosses the origin. Simple. Yeah, simple question. See, first let's picturize. See, this is our charged ring. Radius is given 3a. Charge is q, and yeah, and this is at xy plane, and yeah, point charge q is moving towards the ring z-axis. So yeah, this axis starting from 4a. This is 4a distance. So point charge q is here. So let me. So yeah, charge of ring is capital Q and point charge is small. The minimum value of v such that it crosses the origin. Yeah, this 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 q should cross the origin. That's all. Simple. Yeah, from work energy we know that. What do we know that? We knew P initial plus kinetic energy initial, potential energy initial plus potential kinetic energy initial is equal to potential energy final plus kinetic energy final. We know this, right? Simply we can, yeah, use this formula. See, what is the potential energy at initial? Initial means, yeah, if charge q is here, so initial potential energy is, yeah, kq by how much? 5a. See, this is our formula, right? We have formula, yeah, kq divided by root of r square plus x square. This is a formula, right? So yeah, this question, see, kq upon root of r square plus r square is 3a square plus x is 4a, 4a square. That means kq upon root of, yeah, it will be 5a. Easy. So initial potential energy is kqq by 5a plus initial kinetic energy is half mv square. Yeah, is equal to. And final potential energy will be at center, right? kqq. Yeah, q reached at center. 3a kq by r. That's formula. And final potential, final kinetic energy will be zero because it stopped the. Then yeah, we can just rearrange this. Okay, half mv square is equal to k q q by a 1 by 3 minus 1 by 5. So v square is equal to 2 k q q by m a 5 by 5 minus 3 2 by 15. 2 by 15. So the final equation will be root of 2 by m k q q, that will be 2 k q q by 15 a. Yeah, this will be the final equation. Is the final answer. Which option is satisfying that? Okay, q square. Okay. Okay. Both have same charge q. Sorry, both have same charge. Okay, so q is equal to q here. Both are q only. So v is equal to root of 2 by m 2k q square upon 15a. Q square upon. Okay, you have to root k. K is 1 by 4 epsilon, right? Root of 2 by m into 2q square 4 pi epsilon 15a. Yeah, option C. Right. 2 by m 2q square 15 4 pi epsilon a. Yes, C is the right answer. Yeah. Next, dipole. Okay. Dipole 2 point charge is separated a very distant. See, dipole moment will be charged into separation between the charge into, yeah, magnitude will be charge into separation between them. Easy charge into separation between them. As simple as that. For example, C minus Q plus Q. Okay, this is the identical solution, typical solution. The magnitude of dipole moment will be how much charge into separation between them. And if it is minus Q plus Q separated by 2D, yeah, magnitude will be Q into 2D, charge into separation between them. Okay, easy. Next, you have to discuss electric field due to dipole. This is dipole. Okay. P. So electric field along axis will be towards same direction, and EA, electric field along axis, will be 2 kp by r cube. Yeah, same direction. 2 kp by r cube. And along perpendicular direction towards opposite, E perpendicular will be minus kp by r cube. Right? Yes. And at a given any point, this is P, making angle theta. So at point here, net electric field, which is making alpha angle with the displacement vector R. Okay, here this is E net. Here formula is E net is equal to kp by r cube into plus 3 kp into r cube, kp by r cube into root of 1 plus 3 cos square theta. And tan alpha will be tan theta by. See, once more I'm repeating. E net will be kp by r cube into root of 1 plus 3 cos square theta. Right? See, if along axis theta will be 0, right? Yeah, along axis theta will be 0. N is equal to kp by r cube root of 1 plus 3, that is root 4 into 2, that is 2 kp by r cube along axis. And along perpendicular direction will be theta will be 90, right? So 3 cos square theta is okay 0, so root 1, that is kp by r cube. Yeah, find out direction, we know. Yeah, tan alpha is tan theta by 2. Wow. From along axis tan 0 is how much? Tan 0 is how much? Yeah. Tan 0 is not defined, right? Anyway, yeah. Long axis, long axis, yeah, electric field is, yeah, same direction of P, perpendicularly, yeah, opposite direction. Easy. Yes. This is our next question. A point dipole P. Okay, okay. Easy, easy. Okay, before that, we have to potential due to dipole. Yeah, potential due to dipole. So dipole P, yeah, V axial is equal to Kp by R square. And V perpendicular is 0. V perpendicular is 0. And at a given angle theta, potential is equal to Kp by R square into cos theta. Okay, cos 0 axis, so Kp by R square, perpendicular cos 90 0, 0. Easy, Kp by R square into cos theta. Easy? Yes. Next, dipole. If we place a dipole in uniform electric field, if we place a dipole in uniform electric field, what will happen? Yeah, net force will be 0. Net force will be 0. And there is a torque. Its equation is, yeah, P cross E. Easy. And potential energy. And potential energy will be, yeah, minus P dot E. Minus P dot E. And see, this is the electric field. This is, yeah, theta. If I given a theta displacement, it will oscillate. The time period of that oscillation will be 2 pi under root, yeah, I by E, where I is moment of inertia. See, okay, these are the dipole in uniform electric field. Net force will be 0. Torque will be P cross E. Potential energy will be minus P dot E. And for oscillation, time period will be 2 pi in the root of I by B, where I is moment of inertia. I is moment of inertia. I is moment of inertia. Okay, easy. Yeah. Let's get into our question. This is our question. So here actually in question P is given as minus P0 x cap. Anyway, see what's question. The potential and electric field due to this dipole on the y-axis at a distance dr respectively. Yeah, potential. See, so P is given as minus P0 x cap. Minus P0 x cap means, yeah, okay, here. Okay, potential y-axis direction. Okay, this y-axis at a distance d here. You know that potential is 0. Okay, at perpendicular direction. And electric field, we know electric field D will be how much? Kp by r cube, right? Minus Kp by r cube, or along this direction. Minus, yeah, P by 4 pi epsilon, yeah, r cube here dd cube. 0, then not this, but magnitude, vector wise. So B is the right answer. B is the right answer. Okay. Yeah, next question. Wait. Okay, this is our next question. We know that time period for small oscillation is how much? 2 pi in root of I by P. Okay. So for this question, an electric dipole is formed by two equal and opposite charges q with separation d. The charges have same mass m. Okay. So this is our dipole. Suppose separated by distance d. Charge q, mass m. So it's is equal to q into d. Easy is equal to q into d. Moment of inertia we have to find out for time period. Right? It will be m into d by 2 whole square plus m into d by 2 whole square. Right? At center. So md square by 4 into 2. That is md square by 2. So we got moment of inertia and we got p. And we know that time period is equal to 2 pi into root of I by PE. Right? And we know that time period T is equal to 2 pi by omega. So omega is equal to 2 pi by T. Or else we can equate here, right? Time period T is equal to 2 pi by omega. 2 pi by omega. 2 pi we can cut. So omega is equal to root of PE upon I. Right? Yeah. Uniform electric field E. So PE will be QD into E by moment of inertia is md square by 2. So dd we can cut root of 2qe upon md. Root of 2qe upon md. Yeah. So option B is the right answer. Okay. Moving towards next question. Electric field is given dipole angle 45 degree. The value of electric dipole moment. Okay, dipole moment is again given. Yeah, potential energy we know. Potential energy is equal to minus P dot E. Is minus PE cos theta. Minus PE cos theta. What is P? Minus 10 raised to minus 29 into electric field is given 10 raised to 3. What is cos theta? 1 by root 2. Cos 45, right? Cos 45 1 by root 2. So minus of 10 raised to minus 29 minus of 10 raised to minus 26 into 1 by root 2 we can write 0.707, right? So it will turns out to be 7 into minus 10 raised to minus 27 into minus 7 into 10 raised to minus 27. Yeah, this option is right. Easy. Okay. Okay. Easy peasy. Yes. And next. Yeah. Potential energy. Potential energy. C. Okay. Plus Q separated by distance R. What is potential energy? Potential energy is simple Q by R. As easy as that. If it is a minus Q and separate distance R, potential energy will be minus Q by. As easy as that. And we know that change in potential energy will be equal to minus of work done by conservative force. Change in the potential energy is equal to work done by external agent. Okay, I've discussed it in the earlier part. Let's get into our question. This is our question. Three charges Q plus Q and plus Q rest at the vertices of a right angle isosceles triangle as shown below. The net electrostatic energy of the configuration is zero. The value of Q is. The net electrostatic potential energy of the configuration is zero. So net is given as zero. Yeah, the net electrostatic potential energy of the system is zero. Easy. So C. This is our condition. Q, Q. This is an isosceles triangle. So L root 2. And we know that, yeah, the pairs will be n into n minus 1 by 2. So it is actually three charges. So 3 into 2 by 2. We have to find out three pairs. Right. First pair will be KQQ by L plus KQQ by root 2L plus KQ square by L. And we know that sum of this is 0. Why? Yeah, total is 0. Total is 0. So Q upon L, yeah, Q plus Q by root 2 plus Q is equal to 0, right? It is Q equal to minus of 1 plus 1 by root 2. It is Q equal to minus of Q into root 2 plus 1 by root 2. What is the value of Q? Okay, so Q will be minus root 2 Q upon root 2 plus 1. Yeah, it's option B is the right answer. Easy. Yes. Yeah, next, equipotential surfaces. Just some points. Yeah, locus of points in space having same potential is called equipotential surfaces. Okay, equipotential surfaces is perpendicular to the electric field lines. For a point charge, equipotential surfaces is, yeah, concentric spheres. For line charge, equipotential surfaces are, for a point charge, are equipotential surfaces. For line distribution, these are equipotential surfaces. Right, that's all. Then work done in moving a charge from one point to another on an equipotential surface will be 0, because delta W is Q into delta V. That means delta V is 0, so work done will be 0. That's all. Yeah, next, what is flux? Yes, flux is total number of lines crossing a surface perpendicularly. What is flux? Flux is total number of, yeah, electric field lines. Total number of lines crossing a surface perpendicular. That is flux phi. Right. Okay. We know that phi got a formula. Yeah, phi equal to E vector dot area vector. That's all. That is phi is equal to EA cos theta. And what is the direction of area vector if xy, if area is easy, if area is situated in xy plane, then the, yeah, area vector will be on z axis. Theta is angle between E vector and A vector. Okay, phi is equal to EA cos theta. Yeah, we have a question. See, electric field is given. This is our electric field. The ratio of flux of reported field through the rectangular surface area point 2 parallel to YZ plane. So first area parallel to YZ plane means parallel to YZ plane. Okay. So area 1 is point J cap. parallel to YZ plane. Okay, parallel to YZ plane means, yeah, I cap. Yeah, area vector. Then A2 will be parallel to XZ plane. So the area vector will be perpendicular, right? XZ means 0.3 j cap. Okay, it's given E is equal to 3 by 5 E0 I cap plus 4 by 5 E0 j cap. And we have to find out the ratio of flux. Okay, A by B. It's given as, yeah, ratio of flux is A by B. We have to find out where A is. Simple. So we have to find out the ratio. Then first, what is phi 1? Phi 1 will be E dot A1, right? So we are doing dot product. So I cross J is 0. So just you have to dot, yeah, I dot I. That will be 3 by 5 into 0.2 I. Yeah, I cross I 1 only. Right. Next, phi 2 will be E0 is here. Phi 2 will be E dot A2. Yeah, here I cross J0, J cross J1. So 4 by 5 into 0.3 E0. So phi 1 by phi 2, which is equal to phi 5 we can cut, E0, E0 we can cut, 3 into 0.2 by 4 into 0.3. That is 0.6 divided by 1.2. 1.2. That means actually 1 by 2. That means A by B. A by B is 1 by 2. Means A is how much? 1. A is 1. So A is easy. Next question. One more question from Flex. Simple is given electric field in a region E is 2 by 5 E0 I cap plus 3 by 5 E0 J cap. With E0, it's given the flux of this field through a rectangular surface 0.4 meter square parallel to YZ plane. Parallel to YZ plane means area vector will be 0.4. Parallel to YZ plane means I cap. Yes, I cap. So flux is actually E dot, right? So I cross J 0, I cross I. So flux will be 2 by 5 E0 into 0.4, right? Flux will be 0.8 by 5 into E0. E0 is 4 into 10 raised to 3. 4 into 10 raised to 3. That means 4 into 8, 3.2, 32 by 5 into 100. See, solving this, how much? 5, 20. 32 into 20, 64. 640. Answer is 640. Right. Yeah. Next is our Gauss. Is Gauss law. Total flux through a closed surface. Total flux. Yeah, Gauss law simply saying that total flux through a closed surface. Very important. A closed surface is equal to charge enclosed divided by epsilon naught. And we know that total flux through a closed Q1 enclosed to be epsilon naught. Yeah, flux is equal to E dot A. And for a small area distribution, we can write as flux is equal to total flux, we can write as E dot if area vector S ds, right? It is equal to enclosed upon epsilon naught dot closed surface, right? Okay, yes. So integral E dot ds is equal to charge enclosed upon epsilon naught. Yes. Okay, next question. For closed surfaces and corresponding charge distributions are shown below. Okay. The respective electric fluxes through the surfaces is 515 to 554 then. Okay. Fluxes. We know that total flux through closed surface. Total flux through closed surface. Total flux through closed surfaces is, yeah, charge enclosed upon epsilon naught. Okay. So what are the charge enclosed? I just have to find out charge enclosed. So S1 charge enclosed is 2Q. S2, yeah, minus Q plus Q will cut total 2Q. Here again 2Q. And here 2 minus 2, 6, 6 minus 4, 2. Again 2Q. Yeah, that means charge enclosed in both in 4 surfaces, closed surfaces are same 2Q. So yeah, total flux is also will be same. Yeah, phi 1 equal to phi 2 equal to phi 3 equal to 5. Easy. Surfaces is charge enclosed upon epsilon naught. Okay. Yes. Any doubt? Plus is equal to E dot A. Yeah. EA cos theta. EA cos theta. Flux is equal to E dot A, right? Is equal to EA cos theta, where theta is angle between electric field and, okay, how do we find out? See, if suppose area is, if area is parallel to xy plane, then yeah, area vector will be along z axis. Similarly, if area is parallel means if area is parallel to yz plane, then yeah, area vector will be along x-axis. Easy. Okay. Okay. Yeah. Equipotential surfaces, then yeah, electrostatic potential energy. Any doubt? Yeah, time period is equal to 2 pi root I by PE. Dipole we discussed. Okay, this question we discussed, and anything I missed? No. Okay. So yeah, completed everything, and yeah, we discussed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 questions we discussed. Okay. So guys, thank you everyone. Okay. Thank you.